let's get started then. Okay, so like I said on Tuesday, we're doing general probability questions today. So I have taken end of year grade 11 exams and I have found the trickiest probability questions I could find, but they were all from end of year grade 11 papers. And I thought we could just kind of go through them and see where we could get to. And some of them, there may be new terms and we can talk about those and we can explain what that means. But for the most of this, I think it's all stuff that you would have seen. The tree diagrams are definitely easier than the tree diagrams I gave you on Tuesday. So that should be something which gives you a little bit of confidence, I hope. But let's have a look at this first question. So in all South African schools, every learner is required to choose to do either mathematics or mathematical literacy. At a certain school, it's known that 60% of the learners are girls. The probability that a randomly chosen girl at the school does mathematical literacy is 0.45. The probability that a randomly chosen boy at the school does mathematical literacy is 0.65. 9.1.1, draw a tree diagram to represent all possible outcomes and the probabilities on each branch for 3 marks. So that is your first mission. Just try and focus on this dude. And let me know when you've made some progress and then we can talk it through. Ooh, question. That was rude. Okay, I'm going to give you 2 more minutes on this one, and then we can start talking just about 9.1.1. I'll give you some extra time for 9.1.2. Okay, last minute. See if you can draw your tree diagram. Okay. So the first part of this question is just about trying to get that information into a tree diagram, and then we can start playing with the numbers. So when we're looking at this, it's telling us that people are either going to do maths or maths literacy, and then we have girls and we have boys. So you've got two different options how you could have drawn this tree diagram. You could have either split it up into maths and maths literacy, and then for each of those have girls and boys. Or you could have done it where you split into girls and boys, and then from there into maths and maths literacy. Which route did people take? Did they take number one? Did they take number two? Or did they do neither? Did they feel confused? Let me know. Number two, okay. Welcome back. Hi, Unati. So now we can sort of start putting in some information. So let's see, at a certain school, it's known that 60% are girls. So that means that I would say you can just say 60%, or you could say 6 over 10, or you could say 60 over 100, and 40% are boys. Nice. Okay. Good progress. What do I do with this part? Because then it says the probability that a randomly chosen girl at the school does maths lit is 0.45. So what's that? So what I'm asking is, where would we put that number? Because it's saying the probability that a randomly chosen girl at the school does maths literacy is 0.45. That's not a branch. That means that the probability of a girl doing maths literacy is equal to 0.45. So it's not this one over here. That was the tricky one thing about this question. Then the second part says the probability that a randomly chosen boy at the school does mathematical literacy is 0.65. So a randomly chosen boy who does mathematical literacy, the probability of that happening is 0.65. So what the complicated thing about this question was that it wasn't telling us what to put on the branches. It was telling us our end probabilities for things. So it was a bit mean. Yeah. Then you can work backwards. But do you even need to work backwards if you know that, well, yeah, okay, we can. Let's have a look at what the question says first, though. So the question says, determine the probability that a learner selected at random from the school does mathematics. Okay, we have the two probabilities that they do maths literacy, correct? That's my hint to you. If we know the probability of people doing maths literacy, can we work out the probability of them doing maths? That is my hint. So I'm going to give you 2 more minutes on that. 2 more Earth human minutes. What's happening? What are we going to do? Yeah, good. Why does it not make sense? Because it doesn't add up to 1. Excellent. Good. Good, good, good. It is more than 1. So I don't have any good news for you. This question is faulty. The only way you could actually get an answer is if you put them onto the branches, and then it's not exactly what the question is asking. So it's one of those questions where you're not going to be able to get a correct answer because it's going to be over 1 all the time. It's super mean. It's extremely cruel, Abu. And I'm sure if it was like in a matric exam situation, they would have made some kind of plan that wouldn't have happened to you, I hope. But yes, the idea is that you would take the extras. So this over here would be your 0,35, and this would be your 0,6555, sorry. And you would add those two together. But it's not correct because you're going to get a number that's way bigger than 1. So I just wanted to show you that is what you would do hypothetically, but the question is flawed. They gave you a matric question today? That's cool. 5 marks? Yeah, it's cool. Cruelty. Okay. Good news is that this question does work. Bad news is there's a word that we haven't spoken about in our sessions together, which is if they are independent. So I will go over that very carefully with you when we get to that question. But I feel confident that you can do 9.2.1 and 9.2.2 entirely by yourselves. So what you're looking at is a table that summarizes the results from all the driving tests taken at the test center in Cape Town during the first week of January. So we've got people who have passed and people who have failed. This is called a contingency table. Understand, please, please, please ask questions so that we can talk about it. But your goal at the moment is to do this one and this one. Abu, if you feel confident to do 9.3, please do it. Yes, Uyanda, good job. Okay, I'm going to give you one more minute. Why is everyone else so quiet? You guys are just relying on Uyanda and Abu to talk, but I want to hear your voices too. I want to know what's going on and if you understand or if you don't. Talk to me in the chat. Tebogo, yay! Hello. Okay, let's have a look. Question 1. A person chosen at random from those who were tested during the first week of January, what is the probability that that person was a female who passed? Unati, you can also be a social butterfly. I need your social butterflyness here. So we're looking for the probability that the person was a female and that they passed. So we're going to go to our passes. We're going to go to female. These are our females who passed. So they are the females who passed. And these are my total number of everyone. So the probability is going to be 43 over 98. So that is females who passed, and that is the total number. Okay, 9.2.2. Given that a randomly chosen person is male, what is the probability that he failed? So now we're only looking at males because they've told us that the person is male. So we're only looking at the males. What is the probability that he failed? That's going to be this one over here. So we're going to say 7 out of 39. So that is our males who failed. And this is 39 is the males total. Okay. Does anyone have any questions about those first two questions before we dive into the independent question? Okay. I'm just going to zoom out a little bit so I can write some things. Okay, so we get dependent events and independent events. A dependent event means that the probability of one thing will be affected by whatever happened first. So probability will be affected by the previous thing. So as an example, how many cards are in a pack of cards? $52. Okay, so we have 52 cards. If I take one card out, so I've drawn a card, what is it? What's my probability going to be out of? So let's say that I wanted to know in the first time I draw, so I'm going to draw 2 cards. First card, second card. Okay, first card, and I want to know the probability of drawing a heart. Okay, so what is the probability of me drawing a heart when I draw out my first card? Yeah, 13 out of 52 or 1/4. Okay. Now let's say I drew a heart card. What is my probability of drawing a second heart card? 12/51. So this probability changes dependent on what happened first. They are related to each other. So they have an effect on each other. Independent events have no effect on each other. So that will be like tossing a coin, for example. So when you toss a coin, you are either going to get heads or tails. And whatever you got the one time should have no impact on what you got the next time. It is an independent event. That is what independent events mean. And on your formula sheet, it will look like this. The probability of A and B is equal to the probability of A times the probability of B, if they are independent. So if they are independent, then that will be the case. So they are wanting to know in this situation to show all working and determine whether passing the driver's test is independent of gender. So that means you're going to need the probability of being a male, the probability of passing, and multiply and see if that works. Or you could do female and passing, or female and fail. All of those are fine. But I'm going to give you a little bit of time to try that yourselves before I do it on the screen. So if they are equal, then it will be independent. If they are not equal, then it will not be independent. Okay, I'm going to give you 2 more minutes. Okay, so let's look. Probability, I'm going to do male and pass. Okay, so, sorry, my cat is everywhere this evening. The probability of being a male and passing, we need to have a look, is going to be what? How do I work that out? What's the probability of being a male and passing? Having a look at our contingency table. Yeah, good. So being a male and passing will be 32 out of 98. And you can work it out as a percentage or a fraction, whatever is easier for you to work with. It should come through to about 3265. Okay, then we work out what is the probability of being male. So the probability of being male, looking at your contingency table, what is the probability that you are male? Good, 39 out of 98. The probability of passing. Good, 75 out of 98, because of these people over here. So now we're going to multiply those together. So we're going to see what the probability of being a male times the probability of passing is. And we should get a number that's like 0.3045. So what you're doing is you are multiplying these two numbers. And then all you need to say is that the probability of M and P is not equal to the, what am I writing? Nonsense. Is not equal to the probability of M times the probability of P. Therefore, they are not independent. And that's all we have to do. And that's like a nice guaranteed 4 marks. So as long as you know what you're doing. Do you understand it now? So Teboko, I would not say that, because just because something is not independent doesn't mean it's going to be dependent. It just means it's not independent. Yeah, you could have done females in the same way. You could have done failing in the same way. So you could have looked at females who fail and then looked at the probability of females, the probability of failing. All of those are fine. Okay. Cool. Any other questions about our independent event? Okay. Let me zoom out. If you wanted to take a screenshot, please feel free. Now we can get to some spicy questions. Okay. Events A and B are mutually exclusive. Who remembers what mutually exclusive means? They don't intersect with each other. Good. So mutually exclusive is we've got these two separate situations. They are not going to interact with each other. Okay, they are mutually exclusive. If we're looking at no touchy circles, if we look at it from a formula point of view, the probability of A or B is going to be equal to the probability of A plus the probability of B. So it's just saying that this probability plus this probability would be A or B, because there is no intersection. Okay. So they've given you some information. This is for 3 marks over here. Probability of B is equal to 2 times the probability of A. The probability of A or B is equal to 0.57. And they would like you to work out the probability of A. give you some time to think this one through. It's a very cool question, though. If you get it, you're going to be very happy. Hi, Lorato. It's okay. Oh, boo. I'm not hating what I'm seeing. I'm not hating it at all. Kind of. I'm saying nothing. Exactly. They are kind of like terms. Yes. That is a good way of thinking, Leander. Think of them as like terms. Taboho, nice solid answer. So lots of different ways to do this one. But the key is actually this statement over here. This is telling you that the probability of B is 2 times the probability of A, right? So instead of writing the probability of B, I can just write that. So instead of writing the probability of A plus the probability of B, we can write the probability of B is this, so 2 PA, and this is the probability of A. So we've got 1 PA plus 2 PAs, and we know that because they're mutually exclusive, it needs to equal 0,57. So these are like terms. So I've got 3 probabilities of A, which is 0,57, which means the probability of A is 0,19. Now, if you did it the way Abu did, it's also very smart, nice, clever way of doing it. So Abu said, okay, cool, well, let's make this X. So we've got X and we've got a 2X. And so we had an X here plus a 2X over here, and that was equal to 0,57, and then solved for X. Great way of thinking about it. But that's all you're doing. This is the probability of B because of that sentence. 3 marks in the bag. Take a screenshot if you would like, and then we can move on to our next question. Okay. In a certain sample space, there are 400 people. It is given that the probability of C is 0.3. The probability of D is 0.7. And the events C and D are independent. So I'm just going to write again, because we haven't spoken about independent much. If they are independent events, it means the probability of one times the probability of the other is going to be equal to the probability of them together. Determine the number of people that would be in C or D, and then it's got this. Who knows what that means in probability? Good, that means not. So we are looking for the number of people that would not be in C or D. Those are my hints that I've put up on the board. Try your best. It is a nice question, I agree. There's a trick here as well, but let me first let you try before I trick you. I will explain this one nice and slowly because there are multiple layers to this question, but I just want to give you a chance to first try yourselves. Okay, one more minute. I will tell you that this is kind of important. Oh, Yanda, I do not hate that answer. Not even kidding. Oh, it's okay, Desimonia. It's going to be recorded and you can watch later. But have fun at your meeting. Anytime. Okay, let's try and play with this one. So we know that this is the situation, right? They've told us what those are, so we can work that out. So the probability of C times the probability of D is going to equal the probability of C and D. So that's 0.3 times 0.7, and that's going to give us 0.21. So the probability of C and D is 0.21. Okay. All right. If we want to work out what the probability of the OR is, we do it this way. So the probability of C or D is the probability of C plus the probability of D minus the probability of C and D. So we can put that all into our logic here. The probability of C or D is equal to 0.3 plus 0.7 minus 0.21. That gives us 0.79. But we don't want to know about the people who are C or D. We want to not have those people. So we can just say the probability of C or D not is 1 minus 0.79, which is 0.21. And that's most of the way. However, it said in the question, determine the number of people. And because it said determine the number of people, we then have to take this dude and multiply it by this dude. So now we have to say for number of people, it will be 0.21 times 100, which gives us 84 people. I absolutely agree. I would also tend to go for a Venn diagram because it does make life a little bit easier. So you can work it out that way. And they've told you the information that you can work with. Remember this part over here, that's and. And then when we do this, plus this, plus this, that's all. And that's this question. Anyone have any questions about this one? Let me know. Oh, that's actually fine. Teboho, you can do that, but as long as you minus, so then you take that number and you minus, then you're fine. Yep, perfect. Perfect. Okay. Next question is a beautiful Venn diagram. A local restaurant questioned 190 of its patrons about which meal they preferred. So we have salad, pizza, or burger. 11 did not like any of these meals. 57 liked salad only. 33 liked pizza only, and 39 liked burgers only. There were 20 who liked salad and pizza, 15 who liked pizza and burgers, and 21 who liked salad and burgers but not pizza. Let the number of people who liked all three be X. So you're going to have your 3 circles. Salad, pizza, burger. This dude is X. And it is for 190 patrons. Okay, 2 more minutes. Uyanda, I gotta tell you, I prefer Boo's answer to yours. Okay. Okay, let's try. So let's start play with these numbers. 11 did not like any of the meals. So we've got 11 chilling out here. Done. 57 liked salad only. 57. 33 liked pizza only. 39 liked burgers only. Cool. Next. There were 20 who liked salad and pizza. So now this one over here has to be 20 minus x. There were 15 who liked pizza and burgers. So that's going to be 15 minus x. And there were 21 who liked salad and burgers, but not pizza. So that is just 21. So all we have to do is we have to add them all together. So we're going to say that 57 plus 33 plus 39 plus 11 plus 21 plus 20 minus x plus 15 minus x plus x needs to equal 190. And you will get x equals 6. Exactly. This was the key here. But you would have only lost 1 mark. (7.1.2) calculate the probability that a person selected at random would like one meal only. So that's these people, and these people. So 57 plus 33 plus 39 out of my total of 190. So 129 out of 190. Calculate the probability that a person selected would like salad and pizza, but not burgers. So that's salad and pizza, but not burgers. That's this section over here. So we're going to say 20 minus x. So that's going to be 14 out of 190. Feel free to take a screenshot. Yay, you drew an O-Give today. O-Gives are the best. I'm so glad you got a nice curve. Well done. See, I told you, data handling and stats. You just got to get on the right side of it, and then it's like marks in your pocket. Okay. All right. First one we can kind of talk through here. For events A and B, so we've got the probability of A is equal to the probability of B, which is 0, 4. And the probability of A and B is 0, 1. Are the events mutually exclusive? Give a reason for your answer. Yes or no? Who can tell me? Are these mutually exclusive events? Why no? Because they have an intersection. So it's not going to be mutually exclusive because we have an and. We've got this. Okay. 7.2.2. You are now able to work that out. We have spoken about how to do that. I would like to know if these are independent. So in order for things to be independent, the probability of one times the probability of the other needs, ooh, that was an interesting little drawing we did, needs to be equal to the probability of A and B. Okay, they've told you what A and B is. So they've also told us this. So if we said probability of A times probability of B, that's 0, 4 times 0, 4, which is equal to 0, 16. 0, 16 is not equal to 0, 1. Therefore, no, they are not independent. Last one, determine probability of A or B. Exactly, 0, 7. So if you drew a Venn diagram to help you, you can just add them together. Or you could say 0, 4 plus 0, 4 minus 0, 1. And that is going to give you 0, 7. Okay, feel free to take a screenshot. I think we can fit in another question. We still got a little bit of time. I agree. You can type so fast. All right. Last question for the evening. Going to draw yourself a nice little Venn diagram. So it's good practice of what we've just done. You've got 60 grade 11 pupils. You have swimming, hockey, and tennis. So you're going to have 3 circles. Swimming, hockey, tennis. And X took part in all 3. Work through the list of information that they gave you. Be careful of where they've said only and where they haven't said only. I didn't get 9. Are you just guessing numbers now? Okay, let me start going through this because we're running out of time. Okay, so we had 34 who did swimming. So we have 34 in total who did swimming. 13 did both swimming and hockey. So 13 minus X will go there. 16 did both swimming and tennis. So 16 minus X will go there. 9 played hockey and tennis. 9 minus X there. 6 played hockey only. 12 played tennis only. 4 did not take part in any of these sports, and X took part in all 3. So now we have 34 that has to be in total here. We've got 16 and 13, so that gives us 29. So this is going to be 5 minus X plus X, so plus X. And we're going to add all of those together, and they all have to equal 60. And you should get the beautiful answer of X is equal to 5. So you want to add all of these together. I'm trying to think. Abu, did you have 5 plus X here, or did you write that as 5 minus X? Okay. So I think that's what happened. So everything in here has to equal 34, right? So let me get rid of this for the moment. Let me show you. So everything in this circle has to equal 34. So 34 minus 13 minus x minus x minus 16 minus x is going to equal swimming only. And so when we work that out, then you'll see that this is 5 minus x, plus x, sorry. And that's for just the swimming people. I think that's what happened. Because everything in this one is 34.